In section 1.9, we're going to solve real-world problems involving ratios and rates of change. First thing we want to do is we want to look at our objectives. We're going to define ratio. We're going to define rate of change. We're going to determine rate of change in a given context. We're going to formulate a ratio in a given context. We're going to convert a ratio to a unit rate. Our key terms are a rate of change, ratio, and unit rates. I'm going to hold off on the definitions for a few moments. So I'm going to go back up here to the very top of the page. We'll come back to the key terms in a few moments. As you can see, the first sentence of this section is, a popular question in every math class is, when are we ever going to use this? You've probably said it yourself. I've heard it many times, and I've also said it myself in math classes. But ratios and rates are one part of math that is used on a daily basis. Here's some examples. How much does that job pay? Well, you're looking for dollars per hour. What is the speed limit on this road? Well, that's miles per hour. How much coffee did I have? Well, that's the cups per day. Is my cell phone plan adequate? That might be gigabytes per month. Can I afford to go to college? Tuition plus room and board, all that divided by the semester, will give you different rates or ratios. All these things are important things that you need to know how to do. It is the nature of our world today to think in terms of ratios and rates. On the TEAS, you will encounter a range of real-world problems that involve ratios and rates of change, so you'll want to understand these concepts and how to put them into practice. A ratio is simply a fraction which has a numerator and a denominator. You will see over here on the left is a comparison of the size of two numbers. It can be simplified like a fraction, but cannot be changed to a mixed number. So that's something you need to understand. You can reduce a ratio just like you reduced a fraction, but you cannot change it to a mixed number. It still has to be a fraction, so you could have improper fractions, but you cannot have mixed numbers. Also, a rate is a ratio that compares quantities of two units of measure. And these units of measure are attached to either the top number or the bottom number, and you have to always keep the units of measure attached to the numbers. Your rate of change is a rate that describes how one quantity changes in relationship to another. An example will be the previous section we talked about the slope of a line. We said that slope of a line, an example will be y equals mx plus b, where m is the slope or the rate of change of a line. A unit rate is a rate which shows how many units of one quantity in the numerator correspond to 1 unit of the same quantity in the denominator, such as miles per hour. Think of this as a fraction that has some number on top and a 1 on the bottom, so you would think of it as being reduced to a whole number. But remember, rates cannot be reduced to whole numbers. So just remember, you could have 7 over 1, well, that's a ratio or a unit rate, but you cannot reduce it to just 7. A special unit rate that we're going to learn later on in this section is a unit price. A unit price is a unit rate, but in the unit price case, the money amount is always on the top or the numerator, and the 1 is always the denominator. So an example would be if you had a soda can or a soda bottle that costs $1.50 for a can of soda. So your unit price or unit rate would be $1.50 on top and 1 can or 1 bottom on the bottom. So just remember that a unit rate and a unit price are the same thing. A unit price just has to have money. So now we're going to look at the example of this little chart here. This is a ratio, it's a slope formula. We can see if you read all this stuff down here, you can take these 2 points here and find the rate of change on this particular Kevin's round trip mileage from the weeks since the start of the quarter, the total number of miles he's driven. And you can kind of see this is almost a straight line, so that makes our slope a little bit easier to determine. A formula that you can use is the one that they've got here. If you look at the graph about Kevin's round trip mileage, you can use this. The slope is the change in y over the change in x, or the run, which is the rate of change. Some of you, if you ever had slope in a graphing class, you understand these formulas, and you understand rise over the run. Rise is going up, run is going to the left or the right. In the example that you have about Kevin's round trip, they take the point 7 weeks, or week 7, he has driven 98 miles. In week 3, he has only driven 42 miles. So we want to see the rate of change between this point and this point. Well, if you see this formula down here, the rate in the change of y is 98 minus 42 over the week 7 minus week 3, which will give us 56 miles over 4. And since we want a unit rate, we just take 56 divided by 4 and get 14 miles per week, or 14 miles over 1 week. 14 miles per week is just a shorter way of writing this unit rate. It's more common to write 14 miles per week than it is to write 14 miles over 1 week. But it's going to be your choice however you want to write it. In this short example here about Timmy, he's got some blue and red candies. His bag contains a total of 412 candies. He counts 57 red and 98 blue. So we don't know what the rest of them are, but we just assume there's 57 red, 98 blue. And we have to pay close attention to the way the ratio wants us to write it. In the first example, we have the ratio of red to blue. So our red is 57. That's got to go on top. The first number listed has got to go on top. Second number listed has got to go on the bottom. So you're going to have 57 over 98. If we want blues to red, well, this time the blue comes first. So we got to put the 98 on top and the 57 on the bottom. Now, if we want to know the ratio of just the reds to all the candies, well, we know there's 57 red ones, and we know there's a total of 412. Now, if we can see if we can reduce this fraction, and I checked, and this ratio, or fraction if you want to refer to it as, is in reduced terms. Now, I'm going to let you read this example. It's a little bit more complicated than what most people want to do, but once you set up the ratio that they give you, ratio of gas, oil to gas is 1 to 50, and you can see that it's got 12.8 fluid ounces of oil added to a 5-gallon can, and you can determine what it all is, but I'm going to let you work this one out yourself. And also go down here and work on these practice problems. The first one is very similar to what your graph is. The second one, you have to work with the number of hours in a day. So remember, there's 24 hours in a day and 365 days in a year. And these over here, what you'll need to do is you need to take each one of these, reduce them to lowest terms like you would a fraction, and then find the corresponding one down here at the bottom. So when you match them, you have like 8 quarts to 2 gallons. I can reduce that by 2 on top and get 4 quarts over 1 gallon, which would be this one right here. So I just reduced it by dividing the top and the bottom by 2. You can do that. You also may have to increase it. So if I had this one and I multiplied it by 2, so 4 times 2 would be 8 quarts. And since it just has gallons, I know that's 1 gallon. So that one would correspond here. So this one is not reduced. This one is reduced. I'm going to let you work on those yourself and see if you can be able to figure those out. Here are a few more examples of writing ratios, rates, unit price. So we're going to look at each one of these examples here. In your first example, a high school band has 125 members. 75 of them are women. The rest will be men. So our first question is, what is the ratio of women to total members in the band? Well, we know there's 75 women, and there's 125 members. So the women to men members is 75 over 125. And when we reduce that, just like we would a fraction, I'm going to divide the top and the bottom by 25. I get 3 women to 5 members. This will be my ratio. It's not a unit rate because there's not a 1 on the bottom. It's not a unit price because we don't have anything else. It is just a ratio or a rate. Now, this example here is a little bit more difficult because you have to do some extra work. I want the ratio of women to men in the band. Now, we know it's 75 women, but you have to understand, how did I get the 50 men? Well, if there's 125 total, 75 of them are women, they have to be 50 men left. So now I have the bottom number. So sometimes you have to take the information they give you and find another number that's unknown at the time. So I have 75 women over 50 men. I reduce that by, again, divide top and bottom by 25. I get 3 women over 2 men. Now, I cannot change this to 1.5 like you would a fraction. Remember, rates, ratios, unit rates, unit price cannot be written as mixed numbers. They have to be left as a fraction. So 3 over 2 is fine. Now, this is another example. Carl can drive 366 miles in 6 hours. This time, I want his unit rate of miles driven per hour. So the first thing I have to do is, I have to take this is a rate, and set it up. I want miles over hours. So I put 366 miles over 6 hours. Now I reduce it. Since I want a unit rate, I want a 1 on the bottom. So I take the top number, divide it by the bottom. I get 56 miles per hour, or 56 miles over 1 hour. This is a unit rate. Either way is acceptable. This is the more common way in the real world. This is the way you might see a math person write it, or on your TEAS test. So be careful of which one they want you to answer with. This is an example of a unit price. This is something you probably see all the time when you go shopping. If you see an item on the grocery shelf, down below it you'll see what the unit price is per can, per box, per whatever. That's what you want to look at. You want the one with the lowest unit price. That's the cheaper one. So an example will be a 12-can carton of soda costs $4.20 per carton. I want to know what the unit price of 1 can is. So I know the whole case, or the whole carton, costs $4.20, and there's 12 cans in there, because it tells me a 12-can carton costs $4.20. So put the $4.20 over the 12 cans, and then I divide. Top number divided by the bottom number gives me $0.35 or 35 cents per can, or if you wrote it like a fraction, $0.35 over 1 can. Now, be careful when you're doing the TEAS test. Since we started out with dollars, my unit of measure in my final answer has to be dollars. If you change this to cents, you have to make sure you use the cents mark and not the dollar symbol. $0.35 is not the same thing as 0.35 cents. You would have to write 35 cents, a whole number of cents. So be careful when you're changing your money amounts. I hope these examples will help you as you work through this section.